Hello students, so let's try to solve one problem from JEST 2022, and this problem is from mechanics. So, and this is question number B2. So from the second question from the B part, and this is very nice problem. So there is a wedge of mass 2m and mass m is just going to slide down on this particular slight length, and this length is itself L, and this angle of this particular prism or wedge is 30 degree. So the question is, if this block will come at this particular point, means that this block will come to the lowest point of this particular wedge, then how much, so then what will be velocity of this particular wedge B? So obviously these are frictionless surface. So these all are frictionless. So this is, in this problem, what we have to do, we have to use conservation of energy as well as conservation of momentum. But we have to use conservation of momentum along only along x-axis, because there is not any external force acting along x-axis. Yes, we have gravity along y-axis, so momentum is not conserved along y-axis, but it is conserved along x-axis. And if this block will come down, then this wedge will go towards left, because the center of mass of the combined system will remain fixed, because there is not any external force acting on this. And this is another way to say the conservation of linear momentum along x-axis. So let's try to solve this problem in a very efficient way. So obviously this height is basically, this height h is basically L sine theta or sine 30 degree. So that value is L by 2. So h is L by 2. So we have to use this thing for the conservation of energy. And let us assume this block M is going downward with velocity v with respect to wedge. So velocity of A with respect to B is equal to v. So this is in v is in this direction. So along x direction is v cos 30 I cap direction plus v sine 30 along j cap direction. So this is your velocity of A with respect to B. And we can assume velocity of B with respect to ground is obviously, and we can assume this is V1. So we can assume this is V1, and velocity of B with respect to ground is, let's say, V2 along I cap direction, and obviously it is going into this direction. So we have to write velocity of A with respect to ground in I cap direction, in x cap direction is basically, this will be, this is, we can write V1 cos 30 minus V2. Minus sign is why? Because this is going into this direction and component of M is along this direction. So minus sign will be there. And this is, we have to just use here. So along the x-axis, we have conservation of linear momentum. So if we have conservation of linear momentum, that means 2m v2 is equal to m v1 cos 30 minus v2. And from here, we can easily calculate relationship between v1 and v2. And the relationship between v1 and v2, we can easily calculate. So from here, we can calculate this m, and m will cancel out. And this v2 will go into this direction. So we have, the relationship is basically 2 root 3 v2 is equal to v1. So you can easily calculate cos 30 is root 3 by 2, and we can have this particular thing. Now we will use conservation of energy. So initially the all energy is potential energy. So the potential energy is stored into this particular mass m. So that will be mg h is equal to L by 2. So or you can write directly L by 2 is equal to half m if we are talking about mass m, and we have to just use all this thing with respect to ground. So with so if we are using this particular thing, so we have to write this v1 cos 30 minus v2 whole square plus half m. We can use v1 sin 30 whole square plus we have to just use half 2m v2 square. And this thing we can easily write 2 times v2. So we can just use this particular trick and we can use mgl by 2 is equal to 1 half m, and this particular thing is 2 v2 whole square plus half m. We can easily calculate from v1 here. So that value is equal to 2 root 3 v2 and sine square 30. And here we have m v2 square. And when we will calculate all this thing, we can easily find the v2 is equal to root gl by 2. So this is very simple problem, but real concept is that we have to write each and everything with respect to ground, and then we have to find the use the conservation of energy here. So everything is very simple, but this point everyone must be little bit conscious that how we can write this particular thing. And yes, this is nothing but conservation of momentum along x-axis. So use the concept of center of mass, use the concept of conservation of momentum as well as conservation of energy. You can easily solve this type of problem. Thank you.